Hello everyone, welcome to the mathematics class and I am Sandeep Jaiswal. This video is for class 10th students. Now let us discuss some of the examples. Here is the example 1. Find a quadratic polynomial, the sum and product of whose zeros are -3 and 2 respectively. Here alpha plus beta is equal to -3 and alpha into beta is equal to 2. So using the formula fx equals to k x square minus alpha plus beta x plus alpha into beta, we get, substituting alpha plus beta equals to -3 and alpha into beta equals to 2 in the formula, we get k x square minus in bracket minus 3x plus 2, which will be equal to k x square plus 3x plus 2. If we take k is equal to 1, then the polynomial will be x square plus 3x plus 2. Now let us see the next example. Find a quadratic polynomial, the sum and the product of whose zeros are 0 and √5 respectively. This is similar to the previous question. The only difference is that here the sum of the zeros alpha plus beta is 0 and the product is square root of 5. Using the same formula fx equals to k x square minus alpha plus beta x plus alpha into beta, we will substitute alpha plus beta equals to 0 here and alpha into beta equals to square root 5. We get k x square minus 0x plus square root of 5, which will be equal to k in bracket x square minus 0 plus root 5 equal to x square plus root 5 if k is equal to 1. Thus, the required quadratic polynomial is x square plus square root 5. Example 3. Find a quadratic polynomial, the sum and product of whose zeros are square root 2 and 1 by 3 respectively. Here, alpha plus beta is equal to square root 2 and alpha into beta is equal to 1 by 3. Using the formula fx equals to k x square minus alpha plus beta x plus alpha into beta, we will substitute the values of alpha plus beta is equal to square root 2 and alpha into beta equals to 1 by 3. We get k in bracket x square minus square root 2x plus 1 by 3, which will be equal to k by 3 in bracket 3x square minus 3 root 2x plus 1. In this step we have taken LCM 3 from all the three terms and thus we got k by 3 in bracket 3x square minus 3 root 2x plus 1. Then substituting k is equal to 3, the equation will be 3x square minus 3 root 2x plus 1. Thus the required polynomial is 3x square minus 3 root 2x plus 1. Example 4. Find the zeros of the quadratic polynomial 6x square minus 3 minus 7x and verify the relationship between the zeros and the coefficients. First of all, we will factorize the given polynomial px equals to 6x square minus 3 minus 7x. We will write it in the descending order of the exponent, so it becomes 6x square minus 7x minus 3. Now we have to split minus 7 such that the sum of the two terms should be minus 7 and the product should be 6 into minus 3, which is minus 18. Thus the required two terms are 9 minus 2. Therefore the polynomial becomes 6x square minus in bracket 9 minus 2 outside bracket x minus 3, which is equal to 6x square minus 9x plus 2x minus 3, taking 3x common from the first two terms, and in the next two terms there is no term common, so the polynomial becomes 3x in bracket 2x minus 3 plus 1 in bracket 2x minus 3. Now taking 2x minus 3 common from the two terms, we get 3x plus 1 into 2x minus 3. Thus this is the factor of the given polynomial. Now let px equals to 6x square minus 7x minus 3 equals to 0, or 3x plus 1 into 2x minus 3 is equal to 0. Therefore x will be equal to minus 1 by 3 or x will be equal to 3 by 2. So the zeros of 6x square minus 7x minus 3 are minus 1 by 3 and 3 by 2, or alpha is equal to minus 1 by 3 and beta is equal to 3 by 2. Also, on comparing the given polynomial with ax square plus bx plus c, we get a equals to 6, b equals to minus 7 and c equals to minus 3. Now we will verify the relationship between the zeros and the coefficients of the polynomial. Let us see sum of zeros, which is equal to minus 1 by 3 plus 3 by 2. Taking the LCM, we get LCM 6. So it will be equal to minus 2 plus 9 whole by 6, which will be equal to 7 by 6. And we can write it as minus in bracket minus 7 by 6. Now since minus 7 is the value of b and 6 is the value of a, so it will be equal to minus b by a. Therefore alpha plus beta is equal to minus b by a. Next, let us see product of zeros, which is equal to minus 1 by 3 multiplied by 3 by 2. So it becomes minus 1 by 2, and minus 1 by 2 can also be written as minus 3 by 6. Here minus 3 is the value of c and 6 is the value of a. Therefore we can write it as c by a. Thus alpha into beta equals to c by a. This verifies our question here. Dear students, now you all are requested to do the home assignment given here. Thank you everyone for watching the video, and I request you all to please subscribe, like and share my channel so that you can receive the updates of the upcoming videos.